Good evening, team. Wish to welcome you once more to our presentation under SmartNet Edu Center. So, at a point in time, we wish to continue from where we ended, that is in computer networks. Under computer networks, we had initiated, uh, we talked about the devices, which are nodes that are connected in the network. And on those nodes, we said they are able to communicate or connect to each other through the mediums. The medium can be wireless or can be wired medium. So we are able to connect via cable or via wireless connection, and data is able to be transmuted or transmitted from one area to another, and that constitutes networking. So a network will be two or more devices that will be able to be connected or nodes, and they'll be able to share information. And from there, we said there are different ways of these computers or nodes can be connected together. There can be we can have a star connectivity, we can have a ring, we can have a bus, we can have a mesh, we can have an hybrid, even a tree type of connectivities of the computers. And away from this, we had going to describe the way information can get to move between one computer to another. We had mentioned of a duplex, full duplex, and a single way of data transfer. So those are different ways in which information is able to flow from one end to the other. And part of the nodes, we mentioned there could be end nodes and there are what we call intermediate nodes. So intermediate nodes were able to allow information to be, they are actually like a walkthrough or a passage through which information comes from the source to the destination. So this is what we did in a quick summary of the previous lecture and the ones that we've covered so far. Today we wish to continue with lecture 3, and in starting we wish to welcome you with warm hearts that you could all follow through. And as usual, let's prepare for the questions that will come up in future so that we are able to prepare for the certification that is oncoming. So, on behalf of my team, the SmartNet Edu Center, I would like to welcome you, everyone, to this computer networks 3, lecture 3. And in addition, under the SmartNet Edu Center, we have about 6 instructors and we have extra uh, coordinators. So the video that is being presented, the team needs to approve it and be able to allow us to send to the students or friends or members that are participating in the course. So we have different languages. There's Swahili language. So for those who are able to understand Swahili and you feel it's a better way to comprehend, we'll be able to add you to another team that is able to communicate in that language effectively. We have added Arabic to the languages. So those who can communicate in Arabic, they are free to join a different language group and they'll be able to communicate and feel free to chat. In the English, we have about 4 different instructors. The one who is taking up this one is me, Max Omwape. That is the one you're going to be with through this computer networking 3. Straight away, I want us to get started. So we had mentioned on the computer protocols. So we want to continue with these protocols. And we talked of the protocols as kind of a constitution. So individuals in a country, they have a constitution. Now, a constitution is a guideline of rules and regulations or laws that has to be followed for individuals to live together in peace. We can see that without a set of rules, uh, there could be a chaos kind of in communication or in anything that we get to do as human beings. So you find that you wish to get something, e.g., you have to meet up with someone, there's no specified time. So you're able to communicate with someone, okay, let's meet up at 18 hours, 19 hours. Because of that, 2 people can come at a certain location and be able to meet and finish the business. But without this type of communication or any information, any guidelines that have been put between the two individuals, one will come at 06, the other one will come at 18 hours, and this one will come wait for 40 minutes. Maybe that's the time they agreed on the meeting to last. He comes, he finds he waits for 30 minutes, the person hasn't come. This one comes another time, and it will be difficult to basically get to communicate. So in networks, what we have network protocols. So a network protocol is a set of rules outlining how connected devices communicate across a network to exchange information or resources. So these protocols, they serve as a common language for devices to enable communication, irrespective of the differences in the software, hardware, and internal processes. So what do you mean in line with networks? Well, for starters, each person, as long as you are a IT nerd, you are able to, you can design something, you can work with a circuit board and come up with a computer or any device that you wish. You make a printer, you make a robot, you can make a lot of different things that are in the IT segment, and people accept it and incorporate it. Some are able to make a pen that has a camera, and in that pen, it has a camera, it also has a it can have a speaker, so it can be a mic. You can talk in a pen and communicate, and you can record. So all those small advancements that have been made in terms of devices, we have brought all these because at the end of the day, they are sharing the same information. And that information that they're sharing, it could be pictures, could be which is also images, it could be signals, audio, it could be videos. So because and text messages. So because we have one set of information that we are getting to share between these nodes or devices that are able to communicate via network, there is a certain regulation that has been put around so that whatever you make, the information can be accepted and be understood. So if I have this pen that is a camera recorder, I can get a video, and when I push it on this system will play it. I'll take a video from the memory card, put in the computer will play it. So what makes that information, despite that the device I used to get this information is different? It was a video camera, it was just the memory card of the phone, it was a certain advanced broadcasting media that I got this information from. But when I put on a computer or any other devices, on a phone or anywhere, I'm able to access that. It's because of these rules that have been put across, which allows information to move from one location to the other and be able to be accepted. Now, so basically, we're going to look at these protocols and what they are about. Now, in full summary of these protocols, they have actually five segments of them, or the principle underlying them. So the first one is a message encoding, message formatting, second, third, message timing, message size, message delivery. So when you talk of message encoding refers or one what part of the rules what it will do. In message encoding, it will be that's in simple summary, there will be different type of information. So some information we talked of it can be from the wire cable, so I'm able to talk maybe on the phone, and the phone is connected wirelessly to a tower, and someone, whatever I'm saying, maybe someone on the landline, I can talk to someone on the landline which is on the cable. So what is going to move this information that I'm talking now, because the computer can't understand this information that I'm saying, it has to convert this information into electrical signals if it has to pass through a cable. It has to convert this information, I'm saying, through a wave if it has to go through in the air through an unguided network or mode of medium, sorry, medium of transfer. So because of this information, so it has to be encoded. It has to be taken from a format that I'm able to speak to a format that the machine can understand. And once it reaches the end, this information is to be taken back to the principal state that it can be understood. So that is encoding and decoding. When you come to message formatting and it's encapsulation. So what is more like you are insulating information. So this information that comes, it will be kind of insulated through these protocols. So we are going to insulate this information so that as it moves from one end to the other end, no one comes to steal this information. So we will know where this information is coming from and where it is going to. So we are more like we have engulfed it, we've put a blanket, shielded or covered you're transporting something from one area to another area. So for safety sake, you're going to get this packaging that you wrap it with and you put the details that you want. So that is what we are talking about, the formatting and encapsulation. So you are going to cover it in a simple package that the person will understand. So this is what I send to you. It's money, but I just don't send it as money because when I put on a bus to send money from Lusaka to Kitwe, these people who are going to carry this, maybe I gave them 30 kwacha to carry my 100 and $200 of amount of money to transport for me, but I gave them 30 kwacha. 30 kwacha is too small as a charge for transporting my $250. So what these guys, they might steal that money. But what I'll do is maybe I'll just get a simple thing, maybe a microwave, a pressing iron or something. Then inside I'll wrap it and I'll hide the money inside there. So I'll be sending the pressing iron. So when a person looks at it, will just see a pressing iron. Through that method, I'm able to protect the information that I'm sending through that channel. Because as it moves through the bus, that information goes to the other location. The people who look at it will not see it as something sensitive. And once it reaches there, the person will unwrap it and get the information out. So basically, that is formatting and encapsulation. We move away from there, we come to the timing. The timing is what we mentioned. One computer can be ready. I'm getting this information. Then the other one sends. The other one is not ready. So you find that there will be a failure to meet up in terms of information. So information needs to agree upon at which point this will be sent and at which point will this be received. We'll get to understand the deeper part of it in what those protocols underlining is. So we come to the message size. The message size is getting something to the quantity that you can digest. I'll give good example. That is in electricity, so to say. Take for instance, you get a coil, you connect maybe a fridge or a stove. You get the coils, simple coils that are found in the motor or transformer. Then you get those two coils and you put this is a neutral and this is an live, and you go connect to your stove. First and foremost, what you get to understand is those two cables would have melted way before you even turned on the stove. Why is it that? Because the quantity of what you're passing through them is too large than what the capacity can accommodate. So the same applies with the size. First and foremost, what you cry over is the data medium that you're using. E.g., you want to send a movie. You want to send a movie. This is a normal thing that gets to happen from your computer to another phone, to a phone. Now imagine these two are Bluetooth and you also have a USB cable. The simple question would be, which one would be easy for you to transfer this movie, which is 2 GB, to your phone? Would it be easier to connect through Bluetooth, we send, or would it be easier we connect through a USB cable? So if you get to see the sense between the two, you get to see that it will be easier to use a cable because the cable will be faster to handle the capacity of information. So the size matters because it will look at the time, how much time is going to be involved, which is also in timing, how much time is it going to take for me to get to send this package, and is this package capable of sending? That's why you find sometimes you have a package, a limit capacity of the thing that you can get to send. If I go on WhatsApp, I select the pictures. Maybe at that point in time, because WhatsApp channel can only allow a maximum of 30 pictures or 20 images for me to send. Once I go to 500 pictures, it tells me I've exceeded the capacity. Why? Because there's a limit to how much size of things that I can send. But I can push them in small parts. There are 500 pictures. I can break them in 20, 20, 20, 20, 20 parts, and I'll get to send my information. So this is what is in network. This is you get to meet it. So there is what we call message delivery option. So message delivery option, if I send information, different nodes, we don't know this, but it happens. If I send an email or if I send a picture to you or something, they have to communicate. The first computer that sends information needs to say, I've sent this information. And the one that is receiving the node, whatsoever end node, will also respond to say, I've received this information. And so they're still exchanging. Even after the data is done, they will still send the feedback to report back to say, I've done this. This happens, we don't know, but it gets to happen underneath the gadgets. So this is what all the protocols get to do. They'll be doing one or two of these things, and there's security also involved to allow different devices to get to communicate. So they will do all this through when information is sent and it has all these parameters taken into consideration. You find that it can work on MacBook, can work on a Linux operating system without fear of uh, failure to be understood when it was originally made from a Windows machine. So we have those are the protocols that we mentioned. There is the message encoding, message delivery option, timing, message size, and the information and encapsulation. So that is those. So what is encoding and decoding? And at this we mentioned. So it's to encode the message. It's just actually there is it's actually to they put meaning into the message. So for the machine to understand. So this message has been spoken via words. The machine can't understand. So when you put meaning, you bring it to the machine language. Once it is in the machine language, you are going to decode it. So to decode it is to take it back to the part where the person will be able to understand. So you can use spoken words, writing, pictures, and gestures, and this is what gets to happen as the picture can get to show you. So there's a sender there. His information is encoded so that it can pass through the machine system. And when it goes to the receiver, it's been decoded so that the receiver can get to understand. And at the end of the day, when the receiver gives the feedback or a response, it can go back to the sender. Simple as that. We come to the message formatting and encapsulation. So there is an agreed format between the sender and the receiver. E.g., we talked of a parcel that is wrapped so that it is understood from the first and the end, only these two. So it encapsulates information to identify the sender and receiver rightly. So it has information of the sender and the receiver. A message format will depend on the type of message and the medium through which the message can be delivered. So that is about encapsulation. So we find that there could be adding some segments, so adding head and trailer from the picture that you can see down there. So there's that data is like actually the information that you're saying. It could be a video. So it will add something like a header and the trailer and the trailer. So it will add something that will confuse people in the system. And once the information reaches the person who needs to hear it, it will just separate that data and remove those two so that the person gets what is intended to be gotten. Now we talk of message timing. So also access method. Is that true which determines when someone is able to send a message? So at the time, at which point can I send the message? And when to begin, how to respond to errors, collision. Senders can transmit message faster than the destination can receive and process. So we are actually communicating at which point. So if normally you can speak whenever you have something to say, you find that it will be difficult to be understood. We're talking between two people, and we say communication is the best of any relationship or whatever, which is communication. And we look at the two individuals. This one keeps talking. That is not communication. You are ordering someone to do what you intended them to do. So in communication, you say, you give time, they give a feedback, you go like that. So that is what we want that aspect to be there. So there has to be a response timeout. You say, I give you times, you also speak, we keep like that. There has to be a flow control. There has to be access method. When to begin, how to end, how to all that information will be needed. We come to the message size. In the message side, we said when people communicate with each other, the message that they send are usually broken into smaller parts or sentences. This makes it easy for the person receiving the information to get it. So I have this baggage of information or story that was said, and maybe I'm gossiping. So I have this package of information that I need to tell you, and it's too large. We talk of our course, we are saying it's split into 7 days. If we came one day, everyone would be bored with their own information. So all we are doing is breaking it into different parts. So at the end of the day, you have a complete set of this information. To me, it's a complete set, but we're sending it in pieces, what you can get it. The same thing applies with computers. You find that an example given there, it's a picture. So that picture is being split into three segments so that information it is received nicely and at a time where the computer can process it and repackage it. So we have that message size system, then the message delivery option. So there are different delivery tools for the delivery of a message. And in this delivery of a message, we have the unicast, multicast, and broadcast. So you came to find that when information is being sent to one specific individual who has to receive it, it's a unicast. The multicast is whereby I'm sending to a lot of people, but not everyone who is in the network. So that's a multicast of the information. And what we call, there's also what we call broadcast. So broadcast is just releasing it out open. Anyone who is on the system will get to release to receive that information. And that is what we can see. So your unicast specific to a video, and it can be received direct by to the individual. The broadcast, I'm releasing everything. Even to those who are not part of my system, they are all getting that information. I've broadcasted it. The multicast, even if I'm only sending to only specific individuals that I intend to give the information. So now we come to this wonderful way to the internet, which is part of the network. We have a lot of definitions for the internet, but let's dig into it. This internet has been revolutionized, and it has revolutionized a lot of things. We are moving with, you know, you can get to know anything that you want. You can get to know a rocket science. You can get to check Mumbai beaches. You can just, it's a place or what you want to check. You just browse it and you see it, Montana, places where you've never been. Nowadays, it's even difficult for someone to come and lie to you about something. No, you've watched this, this, and this, and this. Automatically, as he's talking, you start checking. Now, let me check. You mean on WhatsApp, Facebook? What did someone say? Why? Because of the internet. It has made it easy that any information is just on our fingertip. Each time someone mentions something, we can easily browse into it and check it and respond there and then without wasting of time. A long time ago, it should have been very difficult. I don't know how many would have survived being at that point in time. Now we come to know that this word internet, there is an internet which has the small letter, small case, that's the I, and there is another one which has a capital I. Internet, one has a small letter and the other one has a small capital letter I. So small letter I, capital letter I. Now the one that has a small letter I means for something smaller. That's why we're calling it a smaller one. So it's just able to communicate with each other. So when networks can communicate with each other, that's what we call the internet. Now, when we go to the capital lettered internet, there are thousands and hundreds of interconnected networks. So we should know what we're talking about. Do you have internet on your phone? What do you mean by saying do you have internet? This word is highly misused. Are you connected? Would be better. Are you having internet on your phone? Are you connected to a thousand? Are you connected to one another? Hey, something like that. People need to understand what that means. So now we come to these guys, the internet service providers. So the internet service provider, in simple terms, is what is providing this service. Please keep in mind, there is a service provider. Internet should be free. I give example even in the last lecture or the other lecture we conducted or the other course. We said that when we are providing internet or this connectivity that is between computers, if I can connect my computer to my phone and my printer cable I connect, there is networking there because minimum of two gadgets are there. My phone is able to send phone pictures and my computer is able to print those pictures from my phone. So there's a network already established. Now, what we call a service, so these network providers, the ones you know, if it is MTN is providing you internet, Zamtel, we have Microlink, you have different companies that are giving this kind of internet. Uh, they are they are called service providers because what are they doing? I'll give this good example of the water that you receive at home. I keep using this good example because it makes sense when someone understands it. The water that you have, you don't buy from the company that is bringing the water at home. You don't buy that water, no. All those companies, what they do is they get the water from the river, they bring it to your home. Now, that water can be with impurities, a lot of dirty. They clean it, they cleanate it, they clean it until they dump it to your home. But because of what those guys are doing, you are paying for the service of bringing that water to your home. Otherwise, water should be free. You can't buy water, they can't make water. They are only relating or relocating that from that into your place. Now, the same applies with internet because I can connect my cable phone, my cable printer, but if I'm connecting to a printer that is kilometers away, I'll jump into the channels that they have already put. If they have put a fiber, I'll use their fiber to send that information, or I'll use the air for their towers that they have put for networking. So because I'm using that, then I'm paying for the service. So now these companies that are able to manage these channels, because they have made a lot from Zambia to as far as Europe, Mozambique, anywhere, there are fibers that have been laid across the continents, intercontinental fibers, and there are satellites that are running the scope of the whole Antarctica to Asia to sorry to Australia to different continents, so to say. So you find that these are linked by the wireless, they are linked by cables, and people are just have to choose what they want. And there are satellites that are able to pick up from up in the sky and be able to divert this information. So we have different types of these network providers, internet service providers, so to say. We have international network providers, and you see that these are the top guys, and they're able to connect nations to each other or continents to each other. We have what we call the national service providers. These ones, they provide a backbone network and maintained and specialized by companies. So you find that from the top, one is able to do country to country, nation, continent to continent. You come to the national, so it receives in the nation and be able to spread. So it's up to give up. Then there have the regional. So regional just gets to regional internet service provider or regional ISPs. They are smaller, so they are able they are connected to these big national ones, and they downgrade the spread of this data until we have the local ones who are able to bring to our respective home. So you have to know the network provider that you are having and where are they. Anyone can start up and become any local network provider or can be any other network provider until they get to find the location where they have to according to the machinery that they have. Now, we have what we call a layered task in network. There is what we call a layered task. Information doesn't just flow in now. It has stages that it has to move through. So from one point, it jumps to the other, jumps to the other, jumps to the other. And the simple example is what we have in this picture. So in a layered architecture or network model, one whole network process divided into smaller tasks. So we are sending data from point A, machine node in Lusaka, to another node in Ethiopia. We are sending information from Lusaka to Ethiopia through these nodes. This one has a computer, the other one has a computer also. They're getting to receive this information. So that information you're sending, it has to be broken into small pieces, protected. Remember those 5 cases we mentioned of the protocols? We had mentioned that there has to be timing. Remember that there has to be message size. Remember that there has to be a delivery. You remember that there are those different factors that has to be brought in for this information to be allowed. It has to be covered, encapsulated. So there's encapsulation of that information and different aspect that has to be done to this information so that it can move from one location to the other. Now, this information is broken in those layers. We have about 7 different layers for the network side. But let's look at the daily thing that we do, or if you are to write a letter and send to another person. Let's look at how you break that information and see what those layers do. So let's look at the tasks that are involved. So this is the sender. So what does the sender do? Well, the sender will have a paper, will write a letter that you want, wrap it in an envelope, and drop it at the mailbox. Now, where we are seeing that individual, the sender doing that, that is a higher layer because that's the key. It's more like the key points. Now we have the middle layer, which is so this letter will be carried from the mailbox to a post office. So they just drop for those our friends are outside a small mailbox where you just write and drop there. Now someone will come with a car and pick that letter from your home and take it to the post office. So you see that that is what we call a middle layer. Something has to be taken from there and taken to the other system. So they are of each person you see in the system that there are specific jobs that each entity can do that the other one will have to pick up from and go just like that. Now, once the letter is at the post office, you see that it will be carried by the post office. Letter is delivered to a post office, and uh, so it is also going to be
So once it moved from the post office, so it is now reached the post office, which is the lower layer. And once from there, the letter will come to the receiving end. The letter is carried from the post office to the mailbox of the individual who is the receiver. So we put in the mailbox in their home mailbox, and the person will get it and will read it. So when you look at the two, you find that the sender and the receiver, they are on the higher layer side, because these are the ones who are doing the key things that are involved in this information or in this letter sending. One is writing, sending, the other one is receiving to read it. The other two things that have been done, there are different entities that are working around it, because there is one intermediate being that has to collect the letter and take it to this, and so there are different layers. So the same way this information is flowing, that's what happens in the network. We have different layers. So this is just the example that we looked at, and that is how it is spread up. So you see how from the person who wrote the letter to the person who carried it until the person who received the information and makes the final reading. Now, in computers, it was very difficult. I'll give this good example. Uh, like the way we said on the starting, people are developing new computers, new systems. So now it was difficult. How is this information going to be recognized? If I send information from my smartphone to another individual who is going to be using a computer, how are they going to understand me? Because these are not two companies that made them. My computer is HP. My phone is a Samsung phone. These two guys are totally different companies. I don't even know if they have sat together to eat or have a meal as one. Maybe there could be competing between the two. But me, I'm a user of both devices, and I do send this gadget, this information through this device, and I have to receive it from another end, or someone else has to receive it from the other end. Are these people going to meet up and give us this information that we need? So you see that this model is based on the proposal. This proposal was brought back. People sat down in the early 1960s, 1860s. So they sat down and they came up with what we call the iOS standards. That's an international standards of organization. So they come up and made up what they standardized the protocols and put them in various layers, that this can only be done by this can only be done by this can only be done by this. So they came back down. And any device that is made that has to share information, they all have to understand this protocol, these protocols. Whichever doesn't meet, information will not be understood. Those are the times where I send a picture or a PowerPoint presentation on your phone, and when you receive with your phone, you say, no, I'm not able to view it. It's difficult to be accessed by me. What does that mean? One or two of the protocols has not been followed. There is a standard where things are supposed to be understood, but if something doesn't fall in, maybe something is missing somewhere, and you see those standards, those protocols that are there, which will enable you and me to get to share that information. Now look at what these principles or these protocols needed to follow. One, a layer should be created where a different abstraction is needed. So each one has to do their duty, and the other one will pick up from the other. It is as steps or stairs. So you can't, there is no way to jump step 1 to step 6 minus passing through the others. Each step needs to do its job. Now, again, we try to hear that each layer should perform a well-defined function. So each layer should be known. If I step on step 2, step 3, I need to know what needed by to be done by that. And the function of each layer should be chosen with an eye toward defining international standard protocols. So each should have some certain standards that will protect it and go with it. Now, the layer boundary should be chosen to minimize the information flow across the interface. So it has to have like walls or a boundary, so that this information doesn't jump off to the other. So it has to protect itself. The number of layers should be large enough that distinct function needs not to be thrown together in the same layer. So they are expressed, made bigger, such that each can be distinctive and can have its own information that it can do. So these are the 7 layers that we have. So there's the application layer, which is the topmost layer, the higher layer, an application layer, we have a presentation layer, we have a session layer. Now we come to a transport layer, we have a network layer, data link layer, physical layer. And we can see the functions are attached on the side. So when we talk of the application layer, it's a human computer interaction layer where application can access the network services. So this is where you're opening the browser on your computer because you want to check WhatsApp, your YouTube or what, or you have a WhatsApp app or all these apps that you are able to deal with as a human being. You work with a computer or your phone. That is what we're calling kind of an application there because there isn't an application that can easily understand you, make things look beautiful, pictures designed and all that. The computer doesn't even care to know what color the information sent, how did you design when you send something to it. So that is the application layer. So when you're sending something, you're using an application. And once that person receives that information, it will also be sent back to the application. So to the person who is sending, it moves from 7 to 1. To the person who is receiving, it moves from 1 to the top. Because this is how the information will move. So the first one in the 7, the application layer, you go to your browser, you're typing an email, you type, this is Google, this is Yahoo, this is whatever email service that you're using. You use your browser, you type. Now there will be a presentation layer. So you're going to ensure that data is usable format and data is encrypted. So passwords are going to be added so that that picture you send or what you send is clean and kept like that. Then we have a session layer. This maintains the connection, responsible for controlling ports and sessions. So at which point can this information be received? How can it make sure that this information moves directly, come to you, doesn't go to anyone else? The session layer will put up that. We come to a transport layer. So this transmits data using transmitting transmission protocols. So in this part, you come to see that this information will be broken down into small pieces and the information will be able to move from where you are sent to the one who is supposed to receive it. We have what we call a network layer. Now it decides which physical path the data will take, whether it will take the wireless, it will take the different package. So it is the one that decides how the information will get to move. And we come to a data link layer. This one will get to define how the data will be, the format of the data, so to say. And the physical layer, it transmits information now into a computer language. So all these things. So now the format layer is where the physical layer is where you come to transmit it as a signal, electrical signal if it is in the wire medium, or wave if it is going to move through the wireless method. So you are doing all this on your own, on your computer. This happens on any device, any node. So whenever you're on the node, you are doing this. The 7 steps are happening from the 7 to the down. And this information will move through this physical mean to another one. And it will also start from the physical, going data, going to the network, going to transport, going to session, going to presentation and application until this person be able to see it. I send a hi on WhatsApp to you. This hi on WhatsApp, for when I'm typing it, application layer. So I'm writing it, I'm dealing with it. It will start being broken down, everything, understanding the information. Computer uses its language, closes it so that that information doesn't go, chooses who is specifically this information sent to, what's the phone number of this person, this information now, how should this person go, and what time should this person receive, how is the connectivity, what channel are we going to send the information, which is the safest route that this person can receive this information. Is this information, maybe this person already logged with more information, should we send now? Once it does all that calculation, the physical layer will take that information now in the computer language through a cable or a signal, and the information will be thrown to the other, and the person receives it. So that is basically that. Now, these 7 steps, we need to understand them because the OSI standard that we mentioned, the OSI, they say you have to follow the same category. So sometimes, uh, so we use some different ways or to remember it. I start from the physical. I say, please do not trash or throw away the sausage pie away. Please do not throw sausage pie away. It's just like something that helps you to remember so that you know from the physical, please do, that's for data, not, that's a network layer, trash or throw, that's for transport layer, sausage, that's a session, pie, that's a presentation, where that's the application layer. So whatever you use, just remember that if you are going to write an exam for in networking, this will be needed to be mastered. But for learning sake, we know it as such. So this is a bit more advanced I'm trying to give you. But if you see on your right side, there are those physical. There's 1, 2, 3, 4, according to the steps that have been put up about. And it explains the functions and what are playing those roles. So if you come to notice in the physical layer, we have the fiber, there are those pins, the connectors. So we have the fibers and the RJ45, those that are transmitting the cable, the data that is in the physical layer. And when you talk of the data layer, we have those that are routers, we have the bridges. So those are able to transfer the information that we are talking about. So they can be for specific addressing. We have a MAC, and we say that it's found on the network interface on your computer. So where you connect your data cable, that's the network interface, the NIC card. So where you connect the jack, you check the RJ45 pin where you connect on your computer. There is what we call a MAC address. So we have that's where you get your information. And in the network layer, we have the IPs. So you're able to pick your IP addresses, and the information gets to move from one point to another. And you see there are different switches, routers that are doing the smart work per system until the user on top in the application, because that's where we are interacting with Gmail just to check what is going on. I believe we've put it in many simple terms. We can understand it. So we have the OSI layer. So those are the layers. So like we said, that is device A on top. So device A is sending information. So it's on the browser. That is the application. It will go down presentation, session, transport, network, data link till the physical line. Then it will pass through the switches until it reaches the 1,000 miles where the information is. Once it reaches, it will be the person will receive that information through either the cable. And once it receives that information, to start going up, 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 up until they're able to do it on the application, or an email or a WhatsApp message will pop up on their phone. So that is the channel through that information gets to move through. And from there, we can see those are the functions of a physical layer. So that physical layer that we mentioned, the lowest one, it enables bit synchronization. So we're able to change the information, whatever we have into bits, zeros and ones, the language that the computer can get to understand. So it controls the transmission rates and bits per second, how many bits. And we see that there are hubs, repeaters, and modems that can get to run under this physical layer where we're just dealing with transferring computer information via a cable to another segment. The functions of a data link, it frames the data in a way that is meaningful to the receiver. So we don't want to go much, so we have it has physical addresses to both sender and the receiver, so it does the encapsulation. So it will put up something that will enable the receiver and the end to get to do it. So those five facets that we had mentioned, they are all coming to be found in each layer, and that information is getting to be done in such a way. It controls the flow, calculation of the amount of data before receiving, determines the extent of control of the device, everything. And you find that there's a NIC card, so the network interface card handles this layer using the device like switches and the bridges. We mentioned that the switch and the bridge are able to transfer. They are smarter because the switch will get to at least, or a router will get to use an IP. A bridge will get to use a NIC. So the specific address on your network card to get to send information. A router will get to be a bit smarter, or a switch, because it will be kept going to relate with an IP address that is easily changeable on your computer. We have the network layer, so it formulates connections between different devices in the layer, decides their due route where that information can go. Should it I go through the cable channel? Should I go a wireless channel? What is basic options are there? And this layer allowed is correct using the IP addresses. So this one uses the IP addresses, and information is able to, and it breaks information into small packets that can be sent. So we see this layer actually deals with knowing the specific IP address. The previous layer, which is the data link, works with a NIC, which is the MAC address, which is on the network card, which is permanent and cannot be changed. This one is an IP that can be put on your computer and it will get to identify. We'll talk about the IPs later. For now, we just want to understand how the information is coming from one area to the other. And now we're going to understand that information. So this is the transport layer. It accepts data, breaks it into small pieces, puts numbers on it, and once that information goes, so that at the end of the day, it can be repicked according to the point, the moment, the small pieces that it was given. It also provide connection the services by using data transfer. So this one allows wireless transfer and information can be able to move or come to the session layer. So the layer can easily process the establishment, use terminations, connection. So this information can tell you how the information is moving, and you come to see that even those data transfer ways of half duplex and full duplex can allow they are able to work around through the same system. We come to the presentation there. It allows the translation of operating languages. So we have just given a simple example there because when you see the presentation, it is closer to the top link layer. So it's going up to the layer. So you come to see that sometimes what I'm talking, the language, will need to be converted such that this information can go. And the layer, we see that it also encrypts the data into a code. So this information is transmitted into a computer language that can easily be transmitted. And it is going to translate that information to a computer language, and then there is encoding and decoding. So basically, that has been discussed already. We come to the application layer. So this file management by allowing users to access, retrieve, manage files on a remote computer. So this is what a user, person like me, can get to open. Allows users to go ahead with an email forwarding and storage. So I can watch a movie, get something from someone, and I'll use it minus any challenge. And provide distributed database sources and global information about several objects. So this is where someone can make it, and I can be able to lead through it. So you come to see there are a lot of advantages of this OSI model that was made as a standard through which information can be put, the protection, securities can be embedded in, so that if I'm making information, it doesn't just go anywhere. When I'm sending pictures, I can pick a specific location where this information can go. If I put a movie, there's a website, there's a specific channel that people have to follow for them to fetch information from my site and be able to use it. Some will tell me to sign in. So those are specific things because there is an addition of an encryption. So I have to log in and go there. I don't read, doesn't mean that if I'm Gmail there, I can read any person's mail that is there. No, because that information is sent specifically to one individual, and that individual on their own can get to access it. So because of those things that are put across, they make us now, you and me, to be safe in the way we share information. We believe we know that our information that I put across, it is mine alone. Despite that, someone will come and hack in, decode the information before the actual point comes, they decode. Though it's a rare case, but those things will get to happen for some people who get advanced with this type of information. So this OSI enables standardization of hardware devices. So if I'm making a device, I know whoever is making a computer, as long as they add the network card, they are going to put a MAC address on the network adapter, the network card. So where I'm pushing the cable, the RJ45 into the female, they'll get to tell me this is the address that is there. So they standardize this standardization. It reduces complexity in an interface because you find, e.g., the NIC. So if we all know, e.g., the Universal Serial Bus, which is a USB cable, this is also part of the standardization. So it has been standardized to say this is how the device information should move. So they'll put it as a universal type of a cable to be used, despite that others are going to be made, but they'll also follow the same protocol that was being put in this. It is useful to facilitate modular engineering. So modulation, this information can be taken back to the easy understanding. So you're able to facilitate modular engineering where something can be computed from a computer language to be understood in the engineering segment, such that some machines can be made with ease. What I meant is you have a computer, you have a big machine that is operated, maybe a crane or something can be operated with a simple remote. So because of that, things are able to be made with ease. Ensure interoperable, that's the technology and evolution acceleration. The protocols are replaceable with technology changes. So you find that some have been advanced, some have been done what according to the changes that have been made, and supports connection oriented and connection based services. So there is a cable, now the cable, and this allow that kind of sending. Now, what are the disadvantages of what they came up? This 7 layered. You see that this protocol is very long and it's down at the same time. Imagine there are 7 layers. You have to know what is involved, what is doing this, what is that. That makes something more like a bit of a complex. It is only useful as a reference model. So you only refer there because you find that information that is happening in layer 7 is also happening in layer 1, 2. You don't even know what is happening, basically. So it brings up such. It doesn't follow a particular protocol. Many layers have similar or same services. So the splitting into which category it belongs might be another disadvantage that might come up with the OSI model of data translation. And this brings us to the summary of what we have discussed so far. So what you can see, those are layers. So you send information from the seventh layer, the information is coming from the sender, the information gets being broken down to the physical layer. Once the physical layer, this information will move across the country through different routers, switches, and everything. Once this information reaches the other end, the information picks up as in that category until it reaches the intended person. Thank you very much. This is where our lecture ends for today. I appreciate and I for your following through.